Uh, Hello everyone. So in this question we are given that A, which is a point with coordinates 15, -2, and B with coordinates -3, 4. We are tasked to find the equation of a line which is perpendicular to the bisector of the line AB. So if we start by sketching the line AB, the line AB is a straight line passing through points A and points B. So we are required to find the equation of a line which is a perpendicular bisector. So if we talk about a perpendicular bisector is basically a line which is dropped from points A and B, and it cuts the line AB through its midpoint. So, and it also cuts it at an angle of 90, making it a perpendicular bisector. So it passes through point C. So point C, where it passes, is the midpoint of the line AB. Point C is the midpoint of AB. So to find the equation of the line which is a perpendicular bisector, we shall first assume that it has a gradient which I'm going to call M2, and the line AB also has a gradient M1. We all know from the relation of perpendicular lines that the product of their gradients, that is M1 multiplied by M2, should be equivalent to -1. Okay, so we shall first, since we have the 2 points where the line AB passes, so we shall use the points A and the points B to find the gradient of the line AB, which I have called M1. So using A, which is 15, -2, and the point B, which is -3, 4. Let us use it to find the gradient of the line AB. So we shall use the formula for gradient. Since we are looking for the gradient M1, we shall use the formula M1 equals Y2 minus Y1, call it change in Y, divided by X2 minus X1, call it change in X. So we now have to first identify Y1 and Y2 from the two equations, from the 2 points, sorry. So this will be, if we call this Y2, this will be X2. If we call this Y1, this point, this will be X1. Okay, so we can now do the substitution. So if we substitute, we shall end up having Y2, which is 4, minus Y1, which is -2, divided by X2. X2 from coordinate B is -3, minus X1, which is X1 is +15. So if we calculate this, we shall end up having 4 minus -2 is 6, the same as 4 plus 2, which is 6, and -3 minus -15 gives us -18. So if we reduce this, we shall end up having 6 divided by -18, which is -1 out of 3, call it -1/3. So the gradient of the line AB is equivalent to -1/3. So we can now go ahead and look at the gradient of the perpendicular line using this equation, which is M1 multiplied by M2 should give us -1. So if we use that, we shall end up having M1, using M1 times M2 equals -1. If we substitute in the value of M1, which is -1/3, multiplied by M2, should give us -1. We end up having M2 as being equivalent to 3. So the value of the gradient of the perpendicular bisector, which we've called M2, is equivalent to 3. Okay, so if you have to go back a little bit, we can see that the perpendicular bisector passes through the point C, which is the midpoint of the line AB. So we are also required or tasked to find the midpoint of AB, call it C. So the equation for finding midpoint is represented or is given by midpoint of any line passing through any 2 points is given by adding the x values, divide by 2 for the x coordinate, and then also adding the y values, dividing by 2 for the y coordinate. So this will imply that C will be given by, so still using the same points A and B, with this 15 being x1 and negative 2 being y1, negative 3 x2 and 4 as y2. If we substitute to find the midpoint, we shall have 15 plus negative 3 divided by 2, and then we shall have negative 2 plus 4 divided by 2. So if we continue working out this, we shall end up having 15 plus negative 3, that gives us 12, divided by 2, and negative 2 plus 4 gives us 2 out of 2. So finally, we obtain the midpoint C as 6, 1. So the midpoint is given by 6, 1. Okay, so we now have the gradient of the bisector, the perpendicular bisector, and we also have a point where it passes. So meaning that now we are going to look for the equation which has a gradient of 3, and it also passes through the point C, which is the midpoint of AB with coordinates 6, 1. So to find the equation of this line, which is the perpendicular bisector, we shall also assume that it passes through another coordinate with points x, y, and still using the equation of gradient, which is given by gradient is y2 minus y1, that is change in y, divided by x2 minus x1. So if we substitute and use 6 as x1 and 1 as y1, then we use x as x2 and we use y as y2 and substitute in this equation, we end up having m2, which is 3, as being equivalent to y2, which is y, minus y1, which is 1, divided by x2, which is x, minus x1, which is 6. So we do the cross multiplication. Can do the cross multiplication here. 3 is the same as 3 divided by 1. So if we do cross multiplication here, we shall end up having 3 into x minus 6 being equivalent to 1 into y minus 1. So when we open the brackets here, we shall end up having 3x minus 18 being equivalent to y minus 1. So to write the equation of the line, we can decide to make y the subject of the formula. If we use that way of writing the equation, meaning we shall take negative 1 the other side. So if we take negative 1 the other side, on the right hand side, we remain with y equaling to 3x minus 18 plus 1. So our equation becomes y equals 3x minus 17. So this is the equation of the line, of the perpendicular line, to the line AB, which passes which passes through points A and B. So what we've got is the equation of the perpendicular bisector to the line AB. Okay, thank you. Thank you very much for attending. Please subscribe for all our other videos and lessons. Thank you.